All right, let's do some work with some ratios. Now, ratios are, you can write them a couple different ways if you recall, but no matter how you write them, you really should reduce. So we're going to talk first about part-to-part ratios. In this case, we're talking about Macs to PCs, right? Different types of computers. So when you see on the left-hand side here, it says we have 2 to 6. That's written as, or read as 2 to 6, that's what the colon means, but it's not in lowest terms. So recall that if we divide both of them by 2, we would have there is 1 Mac for every 3 PCs, because 2 to 6 is the same as 1 to 3. Okay? So, oh crap, I reduced too quickly. There are 2 Macs for every 6 PCs here in the first one. When you reduce 1 to 3, there is 1 Mac for every 3 PCs, right? That's the reduced pieces. Now, if you change 1 to 3 to a fraction, you would get 1 over 3. So therefore, there is 1/3 of a Mac for every 1 PC. And 1/3 as a decimal is 0.33, so you could say, instead of saying 1/3, you could say there are 0.33 Macs for each PC. So these are the different ways you can talk about part-to-part ratios, and we're going to do that for a few more here in just a second. All right, so now we are going to use a problem that is not necessarily written here, but we're going to go part-to-whole ratios. So thinking back from before, we had 2 Macs and 6 PCs. So that means we have 8 total computers, right? So if we put this as a ratio, the part-to-whole ratio would be 2, how many Macs? Because we're talking about Macs. 2 Macs to 8 total, right? That'd be 2 to 8. So that means there are 2 Macs out of every 8 computers. Again, those are both even, that is not reduced. So if we reduce those, we would say 1 to 4. There is 1 Mac for out of every 4 computers. That should make sense, right? Now, if we have 1 to 4, let's change it to a fraction. So 1 over 4. That means 1/4 of the computers are Macs. Well, let's change it to a decimal. When you change it to a decimal, 1 divided by 4 is 0.25. So there are 0.25 Macs per computer. Well, because it's part-to-whole, remember, part-to-whole is the only time you can write it as a or as a percentage. So 0.25 is the same as 25%. So that means 25% of the computers are Macs, because 25% of the total are the part. All right, now let's go to maybe something that's not. These first two are a little bit confusing, I think. So if we go next, we've got 36 people who were polled about their favorite type of movie. 12 said action adventure, 10 said comedy, 2 said sci-fi, 3 said suspense, 6 said drama, 1 said horror, and 2 said other. So we're going to use those to answer these questions. Now first, we're going to go suspense to drama in the first one. So whatever you start with suspense. So we're going to start with our suspense number. 3, 2, how many are in drama? 6. Now, this is not reduced. 3 to 6 can be reduced to 1 to 2 because 3 and 6 are both divisible by 3. Now, so that means we have 1:2. Fraction form would be 1/2. As a decimal, 1/2 is 0.5. Is this part-to-part or part-to-whole? The only time it's part-to-whole is if you use your total number. We didn't, so this is part-to-part, and therefore the percent form is not applicable. Now, when we go comedy to students, right, that's going to the total. So there are 10 comedies, so 10 to 36. Now again, that is not reduced. So I'm going to again use yellow. I think it's the one that shows up the best. These are both reducible by 2, so we have 5 to 18. So as a colon, 5/18. As a fraction, 5 over 18. Now when I change that to a decimal, I have 0.278. And this one is part-to-whole because we're looking at it to the total students. And therefore, it's part-to-whole, so this is 27.8%. And we'll talk about what these things mean, I think, in the next section. So I want you to hit pause, try to do the last 2 rows based on what we just did, and then come back and see if your answers match mine. All right, double check if that works. You'll notice in the horror to other, that part to part, it's 1 to 2. There was no need to reduce because those came with it. Drama to total students actually started out as 6 to 36, and then I reduced to 1/6. So hopefully that makes sense. Remember, part to whole is when you write as a percent. Everything else stays as a decimal. So let's go ahead and write some sentence. In a meaningful sentence, write the ratio of students whose favorite genre is movie of suspense to drama. So that's the first thing we did, and you'll recall that we had a ratio of 1 to 2. So therefore, there is one student who likes suspense for every 2 students who like drama. Right? Because it's part to part, you can't use percents. You got to just use the numbers that you have in your ratio. Now, if we go comedy to the total number, this was the second one we did. Remember, we were at 27.8%. So we could say 27.8% of all students prefer comedy. The part to whole sentences are so much easier to write because it's just the percentage of whoever you're talking about likes whatever. And there you go. All right, so we're now going to do this problem. We've got 4 health, 1 technology, 3 business, 8 university and transfer, and 12 undecided. So we're going to go write the ratio of students whose program study is health to those who are in public business and public services. So health to business, bad color. So there are 4 health people over 3 business. Now, is this part to part or part to whole? Well, it's part to part because these are each part of the total package. And therefore, we cannot write this in a percent. We would just say there are 4 health students to every 3 business and public blah 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 students. Right? Part to part, you just use numbers because that's how we roll. All right. Part B. Let's write the ratio whose university transfer, so university transfer to the total students. Well, if we go back, if we add these all up, we see there are 28 total. 8 are university transfer. So we're going to go 8 to 28. So that actually reduces down to 2/7 because they're both reducible by 4. But because this is part to whole, we can change this to a percent. 2 divided by 7 is 0.286. So that means 28.6% would be our percentage. As a sentence, 28.6% of students are in university transfer division. All right, let's look at this different table here. Now, one thing to notice in this table is that some of these have units, like bikes and kids. There's no way to get those units to be the same, but sometimes there is, 12 years to 4 decades. We could put those all in years because there are 10 decades, or 10 years in a decade. Sometimes you don't want to maybe put them together, but you probably should. So for this particular case, if there's a way to put them as the same units, you really should. Okay, so the first one, 20 bikes to 15 kids. If we write this as a reduced fraction, that'd be 20 over 15, reduce it, both 5 goes into each one, we end up with 4/3. As a decimal, it's 1.33. In a meaningful sentence, there are 1.33 bikes for each kid. It's whatever comes first, that's what comes first in your statement. In your fraction, this is like saying it's over 1. So bikes on top, kids on the bottom. Now, in the second one, we have 12 years to 4 decades. Well, remember, as I just said, there are 10 years in each decade. So this is the same as 40 years. So if we have 12 over 40, 4 goes into each one of those. So I end up with 3/10, which is 0.3. So we would say there's 0.3 years to each year. And you might say, that doesn't make any sense. Well, let's say that one person says they spent 12 years in prison, one person spent 40 years in prison. That means for each year that the 40-year person did in prison, for each year that they spent, the other person only spent 1/3 of a year, like 0.3 of a year. So that's why it's sometimes, if we would have left it as 12 years to 4 decades, that reduces to 3/1. You would have said 3 years to 1 decade. And so sometimes it makes sense to leave them and separate. Sometimes it makes sense to put them together. It kind of depends on what you're trying to talk about. So 14 cars to 21 trucks. Well, 14 over 21 is 2/3. That's 0.67. That means there are 0.67 cars for each truck. Now, in this one down here, we have 2 dozen donuts to 8 donuts. I'm going to go ahead and leave it dozen to basic donuts. So 2 to 8 is 1 to 4. That's 0.25. That means 0.25 dozen to each donut. So you might say, for every donut that Billy eats, somebody else eats 0.25 dozen. Well, a quarter dozen is 3. So, I mean, we would have ended up 3 to 1 if we would have gone the other direction. So, I mean, again, it depends on how you look at it. And the last one, we've got 11 over 19. They're both in pounds. That's 0.58. So we would say there's 0.58 pounds to each pound. Okay, and there's kind of that one. And I think that, yep, that's the end of that video.